Hi, I'm Lizzie and we're going to be solving this problem. It's asking the decomposition of a hypothetical compound xy is second order in xy and has a rate constant of 7.02 times 10 to the negative third at a certain temperature. So the first part that we're going to do is find, well, already given is our half-life equation for second order reactions. So that's T is equal to 1 over the rate constant times the concentration of the compound. So here we are just filling in our givens. So we have the half-life is equal to 1 over our rate constant that's given, and then multiplying that by our concentration that is given. So when we add this, our units should cancel out and we should get 1,424 seconds. We're then going to divide this by 60 seconds because there's 60 seconds in 1 minute, and we should get 23.7 minutes. So the second part of the problem here is asking how long will it take in hours for the concentration of xy to decrease to 12.5% of its initial concentration when the initial concentration is 0.2 moles. So this is where we're going to use our integrated rate law equation for second order reactions. For second order reactions, our equation is going to be 1 over xyt is equal to kt plus 1 over xy. Above, you can just see, again, I'm solving for this 1 over k xy 0. That will be continued out. We'll see our molarity cancels out. So down below, we are now solving for our new concentration. So we have 0.2 molarity times our 0.125. That is our percentage converted into decimals. So then we are getting a new concentration of 0.250 moles. This is when our integrated rate law equation is going to come into play. So we're writing it out here so we can get a better picture of what we are going to continue doing. And here we are starting to plug in our values for this equation. So we have 1 over the 0.0250, which is our 1 over xyt value here. And then that is going to be equal to our rate constant that we also used in part 1. Then t, which we were solving for, over 1 over 0.200 moles, which was our initial concentration. So we are going to have to manipulate this equation a bit. So we have 1 over our 0.0250 moles minus 1 over our 0.200 moles, and then we're dividing that by our constant value to get our time. So this is going to be given to us in seconds. So we're going to get 4,985.75 seconds. And since we know there's 3,600 seconds in an hour, divide by that to get our time in hours. So when that happens, we should get a final value of 1.38 hours.